Alright, here we have, we're graphing y is equal to 2 3/5 to the x minus 1 plus 1. And then we're going to state the no range and range. Here's what we're going to, first we're going to get points. We'll follow this. We'll get the points from 2 3/5. So basically we're going to leave off the -1 and the plus 1. Okay, and then we're going to translate the graph. Now we're going to translate it by translating the point so that we don't have to draw two graphs. Okay, so the first thing we're going to do is we're going to plug in, let's go 0 and 1, because 0 and 1 are typically easier to use than most. Move this over. Alright, so let's put in 0 here. So we end up with 2 times 3 to the 5th to the 0 power. Well, anyway, that becomes 1, so we end up with 2. So 0, go up 1, 2. Okay, now for this one, we're going to plug in 1. Actually, I'm not graphing it. Sorry, don't graph it. So we're just going to put the points. Alright, then 1, and then we get 2 3/5. Okay, there's nothing to cancel out, so we end up with 6/5. Okay, now we're going to translate the graph. Now the way I suggest doing it is we're going to translate it by seeing what effect the -1 and the 1 are having on our graph. So what I suggest you do over on the side is write in your value. So we'll have our x and our y. So x was 0, y was 2, x was 1, y was 6/5. Okay, now this one right here affects the y value. It's going to move it up 1 by a factor of 1. So we'll say plus 1 and plus 1 here. Okay, now this part is going to affect our x's, but it's going to seem opposite. So since we're actually going to end up adding 1 here. So we'll say plus 1, plus 1. So the effect that ends up happening on our graph is we'll end up with 1 and 2 for our x values, and then we'll end up with 3, and then we'll here add a whole number in this, get the same. So let's go 5 over 5. So we end up with 11/5. Okay, now we're going to plot this part that's already been adjusted. So this has already been adjusted to 1 and 3 and 2 and 11/5. Okay, and so for this. Alright, so these are the points we're going to graph, and we'll go ahead and before we graph it and draw the graph, I'm going to plot the points and then we'll draw the graph and I'm going to label the asymptote. But so we go 1 up 3. So 1, 2, 3. Alright, now if you look here at 2, now it's a decay problem, so it should be less than that, but if I divide 5 will go in there, 2 with a little bit left over. So what we'll do is at 2, okay, our graph is going to be coming down to something like here. Okay, and so then we're going to graph it in just a second. Now our asymptote has been moved. This moves our asymptote. So normally it would be here at the x, but now it's been moved up to right here. Let me draw that in red. So that's our asymptote. So our graph is never going to cross there. So when we graph it, we'll end up coming real close to here. So the graph of our asymptote is the line y is equal to 1. And then the domain, x can be anything, because x can be any value. So x is all real. Now the range, what's the lowest thing y could ever be? The smallest thing y can be is 1. So y, well, it can't actually be 1. Y is going to be greater than 1. Okay, and so then we'll draw on our graph. Alright, so now we're going to cross here and then go up. It should be a little bit smoother. Alright, but the biggest thing is it never crosses 1. Alright, let's look at this one. And first thing I'm going to do is I'm going to come up with some values for x and y. Now again, what we're going to do is we're going to use this part and then translate it using the 1 and the -3. Okay, so what I'm going to do is come up with some values. Now the first thing I'm going to choose for x is 0 and 1. Okay, so if I put in 0 here, that ends up being 1. So 3 times 1 is 3. So at 0, 3. And then if I plug in 1 here, I end up with 2/3 times 3. Those cancel out, so you're left with 2. Now, if we were plotting this, we'd be in business. But we're not. So we're going to have to adjust it. Remember, this just adjusts the x values. So we're going to end up subtracting 1 from both x values. So we end up with our x's being -1 and 0 for our domain, and then our range, okay, we're going to subtract 3 from it. So 3 minus 3 gives us 0. 2 minus 3 gives us -1. Okay, and so we're going to plot these as our points and then draw in our asymptote. Now notice our graph here has been given the 2's, each box or each line's worth 2. So at 0, x is -1 would be like halfway in between this box, and it would be y is 0, so we'd be here. Okay, then when x is 0, y is -1, so it'd be halfway in this box. Now our asymptote has been changed to -3, so y is equal to -3. So okay, so that's 2. 3 would be somewhere in here, so we'll draw a little asymptote in here. Okay, so that's a little bit off right there, but that's the line we'll never cross. So let's go ahead and graph this. So we'll connect it. We'll remember, we're going to come real close to this. I don't know if you can see that, so I'm going to change darker color. Alright, so it'll be here, connecting the points, and then we'll kind of go up there. Okay, and so that would be our graph of this decay function. Now it asks for the domain. Remember, x can be any value. So domain would be all real numbers. Now, what's the lowest value that y can be? The lowest value of y can be, it can never be where our asymptote is, so it couldn't be 3, so it's going to be greater than 3. So our range, y is greater than -3.